Let's try on the 386DX. First the Watcom version. 320 by 200. Yes, just one repeat. .90, 27 FPS almost. And then the demo JGPP. It's a GPP version that I had some issues with the memset and memcpy, and I combined this one for 486. I will show you later. And it used to be slower than the Watcom, but because the memset and memcpy with 386 compilation is doing something bad. But now there is improvement. 320 by 200 again. You might already see that it is faster. Sorry for the flickering, but I don't have a capture device for those. I don't know how to do it. Yeah, it's quite smooth for a 386. 39.71 frames, almost 40 frames from 27. Wow. Why don't we try something else for fun? I have high resolution, but I'm going to select 640 by 400, the lowest high def I can take. And you see, it's slow, but it's a 386, man, and I haven't optimized it yet. There are more ways to optimize it. For the 386, I would think, or one would think it would going to be 2 frames per second or something. And I haven't done extreme optimization. I have some ideas. Would be possible. The 320 by 200, you can do some mode X, switch to mode X resolution, and there is a 320 by 480 there, and you can write 4 pixels at once. And then there is the VGA 16 colors. I was thinking with the bit plane mode. That could be an alternative one. to optimize this. And that one, I think there is a 640 resolution in the 16 color VGA. 640 by 350 or even more by 400. And it needs some work, so it's amazing that it runs on the little 386 slowly, but less slow than I expected. But there is potential for more. 11.37 frames per second. That's an average, of course. And now I'm going to show you in the Pentium. It's a Pentium 166 MHz. And where is it? Okay. I can find the SI here, but I have this one. And this has a PCI graphics card, an S3. Is it an S3 VESA thing? I don't remember. And this is max 900 frames per second. I think that's when it's bleeding at 320 by 200, according to my tests. So this is going to be much faster, but I will show you something. So, I have 3 executable now. I will show you the same problem again. Now, this is the Watcom 320 by 200 benchmark. I'm going to put 4 or even 3 repeats, because if it goes too fast, I need enough time to have passed so that the average is going. It already went there so fast, and it will stop after 3 runs. 346 frames per second. Now, the JGPP, the one that is compiled for a 486, and I also tried compiled for a Pentium, but it's the same. Actually, compiled for a 486 does a bit better on the Pentium. I don't know why, but it doesn't have the issue with the memset I described. So this finally does a bit faster than. If I combine, I will show you. 394 from 346 394, and now I have this version on demo J3. This is compiled for 386 on the DJGPP side, and this have this also on the 386. It would do less. It would do 24 frames per second instead of 27 from Watcom, and instead of 40 frames per second from the good version. You will see the difference in the Pentium, I think. Let's see, because I don't know if it works now. Maybe you will see that it's instead of 346. Okay, you see it's slower. It's fast, but it's slower. We got 346 frames per second on Watcom. It's going to take longer with the 3 repeats. We got with the same DJGPP compiled, but with a target 486, even a Pentium target is good. The issues we had with memset, I will show you later, they are fixed. But for some reason, compile for 486 does a bit better. And now we have a compile for 386 running on the Pentium. And the difference is vast. From almost 400 frames per second, it's 98 frames per second. From 396, 98, it's 4 times less. Okay, isn't that weird? I'll show you why this happens. But now For test, let's run the best version. Look, 640, the lowest highest. Yes, one repeat. Oh my god, 640 on the Pentium. Pentium 166. On my Pentium 3, this is like, it's a beast. .72 frames per second, good. And finally, we can run the highest. Number 5, 1280 by 1024. This is even better than 720p. That is 1280 by 720. On the little Pentium. Okay, the Pentium is a beast. Now this is not going to be very fast, but it's viewable. It's viewable at an extreme resolution. And I could optimize it more. It's the same as when we were running the 640 and the 386. And it looks so good if you see on the screen. Such sharp pixels, especially in this monitor. That runs well on my Pentium 3. I think Pentium 3 is it 500 MHz or 700? This managed to get 50, 60 or 70 frames per second. I think 56 to 60 or something. After also running the MTR or fast read, I have both. The thing that accelerates something on the motherboard, so that the video bandwidth is much better, much faster. That machine is a beast. We are struggling with our modern PCs to optimize some code. The browser doesn't work. If you click on the browser, and here we're rendering the polygons in high resolution on the Pentium. These things, if you port on modern PCs, the animation goes. It goes like that. It goes like madness. And here is extreme high resolution on the Pentium 1. And it's not bad. .28 frames per second. Wow. By the way, this is how the 386 compiled version goes. That's the 386 compiled version. With the faulty memset and memcpy. Which I will show you later in Godbolt. Why. But I don't know why. I will show you how, but I don't know why the compiler is doing that. So that's the same 1280 by 1024, but with the 386 compiled version. It is not, the good version is compiled for 486, not Pentium. Even for Pentium it works fine. It's that the memset and memcpy implementation changes for some reason. It's like 6.90 frames. I stop it there instead for 13. So it matters. So, the thing I discovered by accident, and I'm going to show you here. In my code, at some point DJGPP was producing slower code than Watcom, and usually it could be that a specific algorithm is compiled faster on Watcom. It's the generated code is better. I thought initially, but then I realized at memset and memcpy on my DJGPP project is doing something pretty bad, pretty basic and slow. And here it is. It's using the assembly called repeat store byte. It's storing byte by byte. Okay, and usually these are things you can optimize to store dword by dword. Dword is 32-bit on the x86 and word is 16-bit, but only on the x86, the convention. So I would write even a C loop that would write 32 bits at one, and I would overcome the memset of the DJGPP. And the same happens with memcpy. For some reason, it does a rep moves B. It writes byte by byte, and I was always under the impression that there are some things you have to trust the compiler. And memset and memcpy are the most basic commands used everywhere. You want to fill the RAM, you want to copy a big block of RAM in another place, and the compiler does it the best. Even if there was an offset, even if the copy wasn't aligned, it would write some bytes and then words and then go and write the full 32-bit blocks at the correct places. It would do its magic. Especially a compiler like DJGPP, which is based on GCC. But I noticed, I thought at first, what about optimization? O2. It's a rep moves B. O1. It's a rep moves B. It writes byte by byte. It's unoptimal. How about this? It calls a memcpy function somewhere, which I don't know what it is. But look at this now. This is what I found. I was compiling with a target 386. It's a rep moves B. If you compile with a target 486, it's much bigger, of course, because it has to take care of some... it might seem slower, but it's not. It's much faster, because here it does the rep moves D. Here in the bigger loop, it writes 32 bits at a time. D word after D word. Okay. And that's the same with the 586. Oh, it jumps in a memcpy. But maybe it's a good memcpy this time. I don't know. Yeah, interesting. Because I tried it. It does differently with the x86. What? It does again a rep move. Oh no, it might be outside. The rep moves B. What the fuck does it do? Forget it. I don't care anymore. Because the compiler is a bitch. But in the STNICCC code, on the Pentium 1, okay, the Watcom version, which I don't think there is an option for Watcom here. I searched. Maybe there is. It does it okay. The Watcom would do in 320 by 200 700 frames per second. And the DJGPP, which is usually, you think, okay, maybe it will do a bit worse, a bit better. They are comparable, and maybe DJGPP is optimizing more. The code in general is doing better work. It goes, I think, 200 frames per second. And I was like, what? So vast difference, because it was doing, at least when I was targeting 386 because I wanted to run on a 386, and it was doing a rep moves B when I copy the frame buffer to the video RAM, and I was also using memset to fill horizontal scan lines for the rasterizer. Maybe I can write my own version in assembly though, so that I don't do frequent memset calls. Although it inlines it. It doesn't even do the call anymore, it inlines it, which is cool. And so I was having something that I trusted. I trusted that a memset and a memcpy, especially in modern compiler, it will be kick-ass. And for some reason on the 386 target, It does this thing. So I compiled the DJGPP version at least, which had the problem with a 486. Now this thing, my whole project ran on a 386, still ran, because there are very few instructions that changed in the 486, very few instructions that are missing from the 386 and exist in the 486, and they are not common instructions, so the compilers never use it. So if you build for 486 or 586, sometimes it will run. Most times, maybe there is a case, it will run on 386. So this thing fixed the DJGPP to have a good memset and a memcpy, and this is the one I'm providing on my GitHub release of the STNICCC, so that it gives the good speed. It does it right, and it's fast in every platform. Okay, this is so weird, man. But let's see, LCC. If I do it on the GCC, it does the reps DOS D, and if I target the 386, even the GCC, it does it as a STOS B if it's a 386. That doesn't make any sense. Oh my god, and this is supposed to be... I found that C-Lang. I haven't used it, but I have heard it a lot. Call memset. Huh. It calls a memset. And I don't know what it does. Let's see. Maybe I was trying another X. Maybe this C-Lang. Compilation fail. I don't know, man. ARM GCC. Let's see some ARM code. You can't. I don't know what M32 is. It branches to a memset, so we can't see it. Interesting. Most of them do it, which is it's good and bad, because it might be kinda nice that the DJGPP inlines that. It does a reps DOS D here. And these are preparation depending if the alignment. If you are not on 32-bit alignment, it might write some extra bytes to complete. LCC, what the hell? Jump memset. And a jump, not a call. Compilers are bitches. There are so many. I can see Watcom, but I would have to later. MS Visual Studio. It's calling a memset. This is 1664-bit. So many stuff. RISC-V, this new RISC-V processor. Zig Fugel. You don't get the joke. It's a memset. Anyway, that's what I wanted to show you, that sometimes you gotta check it. You gotta think these are the elementary things that the compilers, the good compilers, will not screw up, and yet they might screw up. You might hear, I might find some old project of mine where
if I knew that fact, it might go quite faster now. If I can recompile it and without changing anything in the algorithm, without improving anything, I can find all stuff that there was something that I haven't noticed. And I tend to notice these things today. You know why? Because I see a plasma running 20 frames per second on the 386. Someone else would say, oh my god, this is so smooth. I say, it's not fast enough. No, I mean, I will see something in a very old machine and I'll have an expectation, a high expectation. Others will see something in a high-end machine and they say, okay, that high-end machine is very slow, it's old. Of course it runs so slow. I will be like, no, it's a beast. Something is wrong, something is off. Sometimes everything is fine, it happens to be slow. But I am suspicious, I'm more suspicious. The more I program for retro, the more I am suspicious. And that's how I find things that I might have missed in the past. Who knows how many C-compiled projects just for the right flags and I don't know. Anyway.
So now guys, we are in a beastie Pentium 3. I don't remember. Is it at 600 megahertz? 700 megahertz, I don't remember. And some kind of PCI, maybe even an AGP card. And now a memset to video RAM does 931 frames per second, just like my Pentium 1. And there are some values that are zero because it's so fast. I'm not going to run the X project because actually if I run it, this happens. I don't know, maybe it's because I'm on EMS mode and I have to go on XMS. But we're going to run STNICCC and I'm going to show you, come on boy, to show you a lot of things. Now, Watcom version, I'll put the 320 by 200 and benchmark how many times? 8 times. Will it be fine? Maybe too fast. It's not so fast. It's the same, okay. I'll tell you why. You can even press escape for results, it doesn't matter. If it has run enough, 664 FPS. Oh, it's not much better than the Pentium 3, but I will tell you, it's the video RAM bottleneck. I want to show something else. Okay, this is the good one, the good DJGPP. Maybe 4 times. Good DJGPP, it's a bit faster. I'll show you. 716 frames per second. And these are not the best results because I'm going to run a tool. But let's see how it affects the DJGPP version that was compiled for a 386. And it had the problematic memset and memcpy. Maybe run it 4 times. From 716, I said 4 times. I'll stop it here. It's enough. $195 frames. And now here is the thing. Since Pentium Pro and more, Pentium 2, Pentium 3, and I think since Pentium Pro, there are 2 tools. There is the fast vid. How much better the screen looks without the CRT. No flickering. Pretty clear on the video. You have the fast vid. Which is enable write posting on certain motherboard, 82450 steppings. No, it says about problems that. So there is something that called write posting. I don't know. I have to read more about it. So there is something. Fast vid enables write posting, banked VGA write combining, and super VGA linear frame buffer write combining on Pentium Pro motherboards based on the 82440 chipset. This will significantly improve graphics performance. Yeah. I mean, I should read that once, but there is some special feature. This is the one, and then there is the MTRR. I don't know which one is better. I think nowadays I run the MTR. I have some batch file, and this will accelerate something in the motherboard so that the video RAM writing is much faster. And we are going to see something. And how much did the DJGPP version, the good DJGPP version? 700 frames. Yes, I'll put it 16 times. Oh my god. That's why I put it 16 times. You even see some offsetted graphics from the tearing. $1,747. 1,704 from 700. I think that was a specific effect that did 700. And here's the other thing. See that the problematic version, the 386 combined with the horrible memset and memcpy, I predict, I'm not sure what I will get, I predict that it will do fine this time, even the same. Because I was trying QBasic code where I was write in QBasic, okay, you usually write byte by byte with poke. There is no easy way to do 16-bit or 32-bit. It's not even 30, it's a 16-bit combined to write many pixels at once. So I was giving an effect on QBasic, writing byte per byte without with the MTR it was accelerated because even the byte writes, which is what the problematic memset and memcpy does. We will see. I think it will have fixed. There is some kind of buffering. I don't know. So that's the problematic one, but it works well now. It doesn't suffer anymore because of this hack that if you write successive, okay, it's a bit worse, 1,497, but it's not like 4 times worse, okay. And for comparison, let's write the what's it. So that one. Maybe this is a bit slower than the DJGPP, but they are all accelerated. And that's the thing, if you have a program that writes, 1,409, okay, but it doesn't write 32-bit at once, at least to the video RAM. This MBTR will help in this case too. But it will still be faster if you route 32 bits, and even for older computers that don't have this feature. Wow. I just want to see MTRU. I will unload it. And I have a FV, fast V, and I want to see, because I remember there were effects, I had some effects, maybe not the STNICCC. I had a plasma or something that would do 2,000 and 3,000 frames per second. And we will also see, we'll see. Let's put the best version. Here is the animation that is... No, it's the same. Okay. And actually I will first try what was that? What the fuck was it? I have the bench here. Oh god, it's going too fast though, it gets zero, my timer, so I don't know if the numbers are correct. No, I think I have to run it for more. I think I have a better one. Oh my god, what is this? Oh yeah, effects, the plasma effect. 2761. I think it's like this. Rotozoomer, written in assembly. This is the one that in a 286 it does 16 frames per second. That is the ultra optimized. And here 1447. Okay. And to finish this video, let's see the option 5, 1280 by 1024. Yes. Just to repeat. Oh, it's much faster. It's not like turbo, but it runs nicely here. Now, without the MTTR, this would suffer a bit. Actually, we can see it. Nice, 55 frames per second. And actually, just for the lols, I unload FastVid. I unload MTRU, I think I unloaded already. I run the good one. Best resolution, yes. See, it works, but it suffers. It's much slower. So especially if you want to do something in high resolution, this MTR or FastVid, whatever you prefer, is doing unloading this motherboard feature. I might have read what that was. It still does well without it, but it does much better. So it did 55 frames per second, and that might be the bottleneck of the rendering itself. "28 frames per second. That could be the bottleneck, because let's try something more. Let's load it again. Let's find this benchmark. If the plasma is fast, maybe the plasma is not fast in high resolution, maybe it is. And put the highest. Okay, it's wrong though, the coordinates are wrong. Because my sine tables are small and some wrong pixels. It's like a glass pattern. But it's still trying to render something. Actually, that glass pattern is amazing. So this is a 1280 by 1024 plasma. 71 frames. Whoa, that's really. Now the rotozoomer is not very optimized because only the 320 by 200 is written in assembly by unrolling some load. The others, if I put a high resolution, it's going to use the C Godbolt one. Well, we can try it. Oh, and it's wrong. Something is wrong there. See, I haven't updated those effects for every resolution. And maybe if we get we got a good number, but it's not a real number. It's I might be rendering 1/4 of the thing. Maybe I hacked it for for 640 by 400 the width and height. No, it's just for 320. Forget it. But anyway, amazing, eh?